Welcome attendees and our chairs, Doug and Andrew, who are joined by our fellow workgroup member and contributor to Blockchain for Hospitality white paper, which is also available on htng.org. Andrew, as this is your colleague, would you please introduce today's presenter for this webinar on how blockchain works?
Thank you, David. So it's my pleasure to introduce Maxim Zavgorodny, who's a blockchain solutions architect at DataArt. And he's been instrumentally involved in several DataArt's customers' blockchain projects. Max is based in Kiev, the capital of Ukraine, and has been with DataArt for just over 5 years. He's also a certified Corda developer, the blockchain platform from R3. So this topic is quite technical and assumes some prior knowledge, ideally obtained at least through the previous webinars on Blockchain 101 and some other ones that we've produced with HTNG and are available on the HTNG channel. But I'll hand over now to Max to take it away.
Yeah, hello everyone. Thank you. Thank you, guys. Thank you, Andrew. So let's start it. My name is Max Zavgorodny. I am responsible for solution architecture, and I have been working more than 10 years in development sphere. And so today we're going to talk about how blockchain works and cover next topics, like shortly review about hash function, transaction, blocks inside blockchain worlds, inside network, difference between public and private keys. Also, we'll touch some concepts like proof of work, proof of stake, proof of authority. Also, we'll consider implementation based on Corda infrastructure and compare it with the Ethereum infrastructure. Also, we'll consider smart contract, how does it works, and main use cases with smart contracts. So obviously the main concept behind the blockchain sphere is chain of the block. It's obvious, but what exactly means? What block consists of? Each block contains a cryptographic hash, timestamp, and transactions list. But before diving into blockchain structure, shortly repeat about hash function. So hash function is one of the main part of the blockchain world. Blocks link to each other by hashes to the current block and hash to the previous blocks. And hash algorithm gets large data to the inputs and produce fixed range of output. This is called hash. And the same hash will always be connected with the same data input. As you can see on the slide, we have on the left side some text like the red fox runs across the ice and the red fox walks across the ice. And after the hash function, we can see the different result because we changed like one word. But in case with one bit of information which will be changed inside the text, the hash will be absolutely different. With hash, we can identify the structure and get some improvement of information which was hashed before. In case with blocks inside the blockchain world, we can be sure and guarantee that our information correctly, so without any changes. Because if we change something, the block will be absolutely different. So basic block structure. As you can see, we have data, hash, and hash to the previous block. Block contains like digital signature, timestamp, and other information. We will touch it on the other slides. Data part contains and represents transaction information. This transaction consists of inputs, outputs from the previous transaction, signature, some specific scripts, and other we will see in details. And of course, we were talking about hashes, and each of the block has hash to the current block and link to the previous block via the hash to the previous block. So let's consider in more details block structure, like block under the hood. The block consists of, I have chosen some typical Bitcoin scenario, like consider Bitcoin block. Block structure consists of and started from magic number. It's for identification type of the data. It's from computer science area. It can be, file or data structure or other identificator for the data. And after that, on the second slide, we can see block size, block header, transaction counter, and transactions list. And block header, it consists of block version number, hash of the previous header, block header, and this interesting thing is Merkle root. Merkle root is hash from transaction root lists. It's simply just hash of current block, which based on all of the transaction in the block. And also we can see current timestamp and nonce in some system field for mining operation, which we will touch on the next slide. And several words about transaction. What does it mean transaction, and what main part of the transaction? How can we understand it and describe it? In case with financial sphere, with payment operation, it can be simple to understand and recognize what exactly going on and underhood the transaction. A transaction consists of inputs and outputs. Also, transaction includes previous transaction hash and some signature and public key. What does it mean, inputs and outputs? For initiated, for instance, Bitcoin payment transaction, we should use unspent input and create output with a destination address. After that, we should prove these inputs, like sign it by our private key and add some additional public script information and send it, broadcast it to the network. And after that, validator nodes in the network will check our signature, check everything inside the transaction, and after that, apply or reject this transaction. It's a typical example of Bitcoin transaction. As you can see, we have input and output, which we mentioned before. And in the input side, we have previous transaction, index, script signature, and output, it's value, script public key. Let's start, consider script public key in the output. Script public key contains the public key or addresses which will be spent. And script signature is some specific signature which unlocking script that allows to spend data from script pub key on the output. In other words, signature just allow to spend funds. If you are an owner of private key and you can sign this transaction, the transaction can be spent. So we mentioned about public and private keys. Let's talk about it shortly. So the main concept behind the SAN consists of private key, public key, and address. So private key is just simple and extremely large and highly random number. And public key is generated from private key, and from public key we generate address. And we can't revert this separation. So in other words, we can't get private key from public key in just one-way operation. How to explain how it works under the hood? We can compare it with we can compare private key with start position balls on the billiard table. Only owner know just these position numbers on the table before knocking it. We can compare it with private key. And after knocking the start position of balls, we can see just mixed balls on the table. In this case, we can compare it with a public key, which was generated from start position before we knock in this game. Of course, this is a simple example, but under the hood, we should use math, and the main concept under the hood is elliptic curve. Elliptic curve based on function y square equals x cubed plus a multiply x plus b, where a and b is rational numbers. And how to understand it in the simplest way. The start position on the table, which we considered on the previous slide, will be G point. It's at our start position for private key. And after some math operation with multiplication x and y coordinates, we will produce public key on our elliptic curve. And as you can see, public key will be generated like a lot of points, like G1, G2, G5 on the elliptic curve. And this operation can't be reverted to the start position. Just only owner of private key can generate public, but can't be reversed. It's some simple comparison how to understand this math, in just basic understanding this math behind the generating and creation private and public keys. So the next part will touch consensus mechanism inside the blockchain network, and it can be different consensuses like proof of work, proof of stake, proof of authority, proof of funds, and many others consensuses. But the main idea should be covered by the next points. If we are talking about consensus mechanism, all the participants should have the same rules, the same agreement. And we can specify the main points. Such agreement, the first one should be agreement, as much agreement from the one group as possible. All participants should be on the same page if we are talking about consensus mechanism. Also, this major point like collaborative. It means all participants should aim to work together. No separate, no for their own individual interests, but work together for all the network. Next major point is cooperative. It means all participants should work as a team more than individual. First team, and just after that think about individual aims. Next point, Gaussian. Each and every vote has equal rate. We don't have any priority for some participant. Every vote absolutely equal. Also, we can say about participatory, where everyone should actively participate in the overall process and support the network. Like implement transaction processing, support transaction, validate, and support active network to be active and to be alive. Let's start from typical example, like the first example of consensus, like proof of work. It's used in Bitcoin and other cryptocurrency. And what exactly going on behind the scene? The main idea in proof of work, miners need some nodes, specific nodes, which are involved to mine new blocks, like prepare and solve cryptographic puzzle to have a policy to package transaction to the block and apply it to the blockchain network. The solve cryptographic puzzle is a difficult process, and if somebody finds the solution will be posted and broadcasted to the network, and the next step after finding the solution to the puzzle will be just verification. And verification is extremely simple process. It can be done by that just by laptop without any additional extra power. And after that, in case when puzzle will be solved correctly and all participants inside the consensus, proof of work consensus, proof of work mechanism prove it, this miner will be notified with the incoming transaction with like reward in some bitcoins or some cryptocurrencies. If you're talking about other blockchain networks based on proof of work. And this mechanism just support the network and produce blocks inside the network. And current approach has a lot of disadvantages, like enormous amount of energy should be spent to compute, this find the puzzle, find solution for the puzzle. And the complexity depends on total network power. If we add additional nodes to the network, we should add additional extra power for calculation, like finding, solving solution to the puzzle. And after that, we can see next generation of consensus, which is called proof of stake and just proof of authority, for instance. What's the main idea? What's the main difference between proof of work and proof of stake? In proof of stake, miners will be changed and just to the validator nodes, and it's instead to mine or find, the result of the puzzle, you should just set up node inside the network and connect some proofs. It can be, in case with Ethereum, it will be address with a positive amount of funds in Ethereum. And this node will be added to the validator networks inside the blockchain network. And this current validator node will be involved to the mining process without calculation and finding puzzle result for solving result. As you can see, the validator will have to lock up some of their coins. And, we shouldn't spend additional energy for this concept. What should you do? Just set up a specific node, like validator node to the network, and this node will be involved to the process. Pretty close consensus is proof of authority, but proof of authority consensus uses for private network in general, and you shouldn't, set up your validator node. You just should, in Genesis file, create some list of nodes which will be validators. It's really fine if you are talking about private blockchain networks. So, solutions, how to implement your solution based on blockchain concepts, or just how to build it. As you can see, nowadays you can use different approaches and consensus and frameworks for it. For instance, it can be core application for enterprise solution or for your private or hybrid network. It can be Hyperledger, it can be Ethereum, like a public network, main network, or private network on different concepts like proof of work or proof of stake, if you're talking about Casper implementation, and other frameworks, but this is the main general and famous frameworks. Let's start example with Corda infrastructure. Just what exactly going on under the hood. Let's start from counterparties. As you can see on the slide, we have counterparty. Counterparty is some kind of clients or node. It can be insurer or reinsurer in insurance industry. It can be hotel, or it can be, some kind of shop. It's just some node instance which can be set up into organization or between them. Also, we can see participants like notary node. It's some kind of system node which provides some system operation inside the network, like double spend protection mechanism or additional verification and transaction validation and other stuff inside the network. How to interact with the infrastructure with your solution? It's simple implementation of RPC calls, remote procedure call protocol. It can be included to your application via HTTP or via shell execution or other protocol. So for the start, your execution, your logic inside the blockchain network, the start point will be flow. Flow starts some mechanism, for instance, booking room into a hotel. It will be booking flow room endpoint, and after that, it will be touched with the initial setup steps like building transaction, sign transaction by counterparty, which belongs to current location. And after that, counterparty provides some inputs, add additional steps. It can be login information, it can be some preconditions or some check-in or verification. And after that, it will be checked by notary. Is everything okay? And in case with correct signature, correct precondition, and contracts which you implement into your application, it will be recorded to the network between participants which were involved in this process. It can be counterparties between different hotels, for instance, or different shops. And after that, how to get information from your storage, from your blockchain storage. It's also can be done with RPC calls via vault services and vault operations. It's some kind of SQL syntax like for execution and getting information about transactions. So as you can see, core infrastructure also it can be not only Cordite, Hyperledger provides some set of instruments and approaches how to build your application based on blockchain solutions with transaction immutability, with private public keys or certificates, with some steps. Just you can use it and create your own solution based on blockchain. A little bit more about infrastructure. About infrastructure. So Corda has some kind of main entities like states. States, you can say about states like some kind of models or objects. It can be room or it can be contract. It can be some object inside our business area. And next, it's flows. Flows, and it means execution and transaction mechanism inside our business logic. Simply, one more time, it can be book the room or check out or check in or sign the contract or some business case inside your logic, which under the hood will be used preparation and creation transaction and committed to the network, blockchain network. Vault entity is described like SQL-like syntax for request operation for interaction with your storage behind your blockchain infrastructure. And one more example with initiator and responder. In this case, we can see Alice, which get data from internal system and create transaction and sign it on his own site, and after that send this transaction to the responder. And responders have to be sure about correctness of the transaction, and the responder provides the same operation like inspect, inspect and verify transaction, sign it, and commit to his own data storage. So as you can see, it's simple transaction model which you can consider in case with the Corda example. A few words about smart contracts. It's smart contract is really a very power concept behind the blockchain world, because program executes as a decentralized process inside blockchain network. The smart contract can be partially or full Turing complete. Turing complete means so you can implement any logic which you want without any restriction. So you can implement buying and selling property, or implement some mechanism to checking everything. It's full Turing complete. One additional benefit of smart contracts inside the blockchain sphere, we don't have single point of failure. If we created and deployed our smart contract to the blockchain network, the smart contract will be executed. And how can we connect it? We can connect it directly via console, but it's obvious for developers and geeks. But for the users, you should implement some application. It can be browser UI, or it can be mobile application. And this application will be like entry point to the decentralized network, and like integrator with our smart contract mechanism via this user-friendly interface. And of course, transparent execution for all of the participants. Everybody can check the smart contract just rules and check transaction history, and all will be transparent and obvious for all the participants. And also very powerful thing is protection, because nobody can modify or change the logic inside our deployed smart contract. Nobody can shut down our application, because it's decentralized, and just it's really powerful mechanism, and it's I think it's future. It's really future. It's typical example with smart contracts. It's operation with buying and selling property. As you can see, we have two participants, like sell house and buy house, and participants have immutable and transparent contract between them. And in this case, we will exclude long chain of proxy participants like lawyer, insurance, and other agents for achieving this goal. In this case, we save our time and money, and result of the operation will be committed to the immutable ledger. Nobody can revert it or change it, which we discussed on the previous slide. It's only one of typical example, but we can implement different mechanism for the different businesses, different spheres, and make our solution more power decentralized and immutable without any single point of failure. For example, just smart contract which written in Solidity, as you can see, it's just typical example of cyber currency, and it's obvious to understand what exactly going on. So on the start line, we can see like typical word like a keyword contract coin, and some fields like variable like public miner mapping to the balance, and function with simple logic when we can send some money from receiver to receiver from unit amount, and some typical checking typical checks, and some accounts like plus and minus amounts and events. So as you can see, it's absolutely human readable, and developers can implement some implementation, some logic for smart contracts with smart contracts. But you have to pay attention to validate and cover it by unit test and check everything is okay, and check some kind of potential hacks and other stuff. How it works on the Ethereum network, just for example in Ethereum. Yeah, Solidity code, which we considered on the previous slide, will be compiled to the Ethereum virtual machine bytecode, and after that this code will be deployed to the Ethereum virtual machine blocks like deployed contract. So in this case you can see how Ethereum will deploy it, and after that we can execute it. Okay, thank you. Thank you for your attention. If you have any question, you're welcome to ask. Also, feel free to ping me by email. I will answer or send you additional materials about this.
All right, Maxim, thank you. That was a great explanation of how blockchain works. We really appreciate your expertise on this topic. We do have a few minutes for questions. If you're in the chat here, please direct those to me, David Kalia, in the chat window, and I'll ask the presenters. I do have a few that did come in during the recording. Maxim, are you ready for the first one?
Yeah, sure.
Great. Well, the first one is nice and easy, but what does it take to become a blockchain developer?
For the blockchain developer, do you mean my personal experience, or could you repeat some connection issue?
Sure. From your expertise, what does it take for, let's say, somebody who's just beginning with, say, front end or back end? What would it take for them to begin their path of becoming a blockchain dev?
Okay, thank you. So I can share advice. It should be great to start, read white papers and clarify about consensus mechanism, about how exactly it works, and after that start to dive into source code, check GitHub repositories, like try to clarify it, and of course start coding, start trying to implement some basic logic with transaction, with preparation and setup. For instance, it's a great approach to start from set up private network and implement some basic logic with smart contracts. And in this case, it will be great start position. But one more additional thing, you should have solid background in development sphere. It will be great if you have long experience with development, and for instance in JVM, if you're talking about Corda and Hyperledger, it's great. Or Python, it will be great too, or Go. And in this case, just learn more and just code more, and in this case you will be achieve the goal. Yeah.
Sounds good. We do have another question here. This is from Charles Errett. How would a smart contract be blockchain agnostic and therefore be able to function across multiple blockchains?
If you're talking about multiple blockchains, do you mean different kind of blockchains like Bitcoin and Ethereum, or inside the one network?
It looks like for the notion of having it cross-platform across Ethereum or some others, like different flavors of Ethereum.
Okay, if you're talking about one, I will give an answer like step by step. If you're talking about one ecosystem like Ethereum, it can be easier to create smart contract or smart contracts which will be communicate between each other. But if you're talking about different blockchain networks and create some extra communication between these different blockchain networks like Bitcoin and Ethereum, it's big issue, and I can share example with financial sphere. For instance, it's example with atomic swap, when we want to implement some logic for exchange Bitcoin to Ethereum without any centralized point like Kraken or Binance or Bitfinex exchanger platforms. And it's really big issue. For solving, we can use some kind of oracleized mechanism. It's some kind of execution external system, but we can face its takedown scenario with some kind of injection with hackers, and we should be aware about it and care about it.
All righty, great. We've got another question here. What led you to become a blockchain solutions architect?
Oh, it was long time. I have been working in this sphere more than 10 years, and I started like as a developer, and I have really solid experience with JVM languages like Java, Scala, Kotlin, and other stuff. And after that, I found this interesting technology, and just my interest provide me additional motivation to investigate and dive into this world. Because in my personal understanding, some kind of blockchain technologies will be matched to the different areas, not only financial, but for instance, insurance. And some mechanism like immutability, transparency, and all mechanisms which we discuss in our webinar will be applied to the different spheres. And that's why I'm interested in this technology. And if you have solid background in some languages, some technology, you can just improve your additional skills in blockchain and to connect, to join to our community. And yeah.
All righty. Well, that sounds exciting. From Charles, again, we have a follow-up in regards from using the same smart contract between different Ethereum flavors or frameworks. We have a question, and it is, does there need to be a console or existing external system sitting on top of the blockchain to make those changes possible?
Do you mean how to change logic inside the smart contract if you deploy it to the network?
Across different Ethereum ecosystems, yes.
Different Ethereum ecosystems, it should be different concepts like main network or private network. Is it correct? I'm not sure about question, to be honest. Could you repeat it, please, more?
Actually, we got a clarification here. Is it related to the smart contracts functioning across multiple blockchains?
Okay, I see. So we can implement it with like different concepts. I can share example how to, for instance, provide some transaction between private network and public network inside the Ethereum world. It can be done with different implementation of frameworks like parity bridges or Polkadot implementation or Radon network or Plasma network. It's some kind of additional layer which can provide guarantees between connection with different network, like private network with public, or your own private network which is located in separated areas around the world. And this network can be closed, and you should share your private transaction between this network. So those mechanisms and frameworks which I mentioned can be used for these aims. Of course, most of them extremely raw, and we can face some issues with performance, with some bugs, but in general, we have experience with it, and we provided some implementation for transferring data between different blockchain networks, I mean Ethereum networks.
All right, and another follow-up we have to the previous question about what does it take to become a blockchain developer. What do you find are the biggest challenges for new blockchain developers, and how long is the learning curve in your experience?
Well, to be honest, it depends on personality, and according to my experience, I saw different examples. If you're talking about high-skilled developer with, let's say, senior with a solid background in JVM or in Python, and this guy really interested in blockchain area, he can start to develop basic blockchain mechanism after 1 month investigation and working with it. And after 3-5 months, it will be great blockchain developer. Am I last word?
Beg your pardon?
Mm-hmm.
That's about it, I believe. Any last questions from the panel or the audience? Any more questions for Maxim, Doug, or Andrew? No? Well, again, I want to thank Maxim for his well-constructed and informative presentation of how blockchain works. We look forward to seeing you all in January for our next episodes in the series of blockchain webinars. We'll be covering how to build a blockchain, and on the next episode, we'll go over governance and regulatory considerations after that. Don't forget to register for webinars at htng.org/webinars. It is plural, so /webinars. On that page, you'll also find our previous webinars listed. You're welcome to review this recording and other episodes in the series. You'll probably know a few people who weren't able to make it to today's live webinar given the holidays. However, you're encouraged to direct your colleagues to access the previous episodes there. If you have any questions or feedback, you can direct those to workgroups@htng.org. Again, workgroups@htng.org. We want to thank you again for everyone presenting and joining us today. Thank you kindly.